Unbelievable. Hey everyone. Wait, hello? Yeah, that's me. Hello. Hey everyone, good evening. How is everyone doing? Yeah, that doesn't sound like a 5:30 p.m. type of noise. But maybe another round, I'm getting some energy. So welcome to the 9th, I believe, mic drop of DSS. Eighth mic drop. I'm already a step ahead of myself. Yeah. It's great. So the mic drop is hosted by the Digital Society School, and for the unacquainted, it's a learning community where change takes shape. It's an interdisciplinary space. You're in it now. And the main focus of it is taking technology and reintegrating it into a social context. Obviously, you can find more on the website. You can talk to me or any of the people in the DSS afterwards. So we have been hosting these mic drops quite regularly. And if you're wondering, who here knows what a mic drop is? All right. I think a lot of people remember Obama dropping it at the end of his term in a correspondence dinner, if I'm not mistaken. But it actually comes from way before that. He did not invent the mic drop. The internet did not invent the mic drop. It was actually a thing that happened in the 80s in the underground rap battle scene. So whenever you had a rap battle, and I am doing so well in dissing my opponent, and I have come up with the excellent rebuttal. So I would drop the mic to say, you cannot possibly come back from this. It is sharp, it is witty, it is conclusive, and even stand-up comedians started using it to do the same thing, essentially. My joke is so witty. And then it was only until 2016 that Obama has used it. It became popular again, no longer a figure of speech. And then we are doing it here, but with a slightly different alteration. We're not particularly comedians or rappers, but we want you to get inspired by the sharp, witty nature of the mic drop. And we want it to be kind of an expert setting, so someone from outside the community comes in with their expertise. We want you to interact. So unlike the original mic drop, when you drop the mic, it's not non-conclusive. We actually want you to interact. Is that the speaker drops the mic, but you guys would have the floor. The last thing is that it has to be witty and provocative, just like the original thing, that you have something that provokes thought. So just to put things in perspective, there's a few other events coming up. This weekend, there is not one, but 2 digital camps. One is a kind of a camp about R and machine learning, given by Emma.
Not machine learning, but...
Not machine learning.
Visualization, if you mean.
Okay, so R is used for multiple things, and it's particularly about visualization. November 17th is a digital physical play camp. November 23rd, there's an Internet of People conference. January 23rd, there's a lot of projects that everyone at DSS has been working hard on. The showcase for that, and it's an open invitation, is January 23rd. And then March 20th to the 22nd is a Learning, Experience, and Design conference. So the subject of this mic drop is the father of that same baby, Pierre Elie. Yeah. Pierre Elie is I have a full introduction here. Applied scientist at the European Space Agency, who focuses on future science missions, and in particular infrared sensors. His work has taken him many places, particularly one place is Madagascar, where he is part of a project called Sunshine in Nosy Komba, which focuses on sustainable development and education in the village of Nosy Komba. So, and I believe his talk covers on the topics of sustainability, kind of drawing on inspiration from space and how do we bring it back to Earth. And it's called Space for Earth. And I think it's time for us to drop. Thank you.
Thank you. It's okay, you can hear me? Yeah?
Yeah.
Was supposed to work, no?
It is, yeah, a little slow. Yeah.
Okay, good evening everybody. Thank you for the introduction. And thank you for the DSS to host me and to allow me to speak this evening about this topic on space for Earth and how space technology support Earth's sustainable development. So I put a picture from the International Space Station where you can see space on the left and the blue Earth on the right. So just to present myself, I'm here. Yes, I'm an applied scientist at the European Space Agency. So you can see me on the left here in my lab, where there is a lot of noise and a lot of optics and leaking nitrogens. I mean, I'm what you can call a rat lab. I like to be really in the dark, hidden, and doing my measurements. But I'm as well involved in the Sunshine in Nosy Komba Foundation, where we help to, let's say, to develop a village, a small village in the island of Nosy Komba in Madagascar. So you can see here me in one of the school to teach the concept of day and night with a globe and a small light. But we do a lot of other projects in terms of hygiene. For example, we set up a maternity there. We set up some scholarship to allow the students to go to study in the high school. So that's why this evening I came with the idea of the topic, what space here on the left can do for the SDGs, the Sustainable Development Goals, to aim for 2030, where is no poverty, zero hunger, good level of education, and good system of health as well. Oh, by the way, here you can see on the picture, that's what it looks like from space when there is a rocket that's been launched. Wow. So just to remind you, the work that has to be done to reach these goals. Just few figures. So that's the mortality under 5 around the world. So you can see for Africa, for example, in 15 years, it went to 156 to 84. While if you see New Zealand, for example, it went from 6 to 4. So you can see there is still a lot of job to do around the world to be able to decrease as much as possible the mortality under 5 years old for a baby. And another one is the sanitation services. You can see that 60% of the population in the world are in basic or limited or open defecation. So you can see that here as well, there is still a lot of work to do to bring this number as low as possible. So what can space do for all this problem around the world? So first, satellites can have a worldwide coverage. You can have a picture of whatever place, of very high mountains, very remote. You can cover everything, everywhere. You can as well, it's 24/7. There is no strike, it's not French. It's all year long as well. And day and night, and as well rain or sunny. So that's, and as well, you can use the satellite as a relay for something. So it can be used as an infrastructure. Even if it's flying, you can use it as something to can send message, or you will see later. And so that's for the satellites. And all the technology that has been developed to be able to bring the satellites in space can, in return, brought back on Earth for specific developments. So if we go for the two main roles, as I said, the first one is to monitor, and the second one is to, let's say, cure by let's say bringing the technology from space to bring it on Earth. So if we start with the first one of monitoring, the first one, very basic, is when you make an image of Earth for different, let's say, wavelengths. So when you look at different things, for example, on the left is the chlorophyll. level in the Mediterranean Sea. So that's a marker of the climate change of how much the temperature of the water is increasing. So you can see that close to Naples, I think, and close to Sardinia, the water is hotter than somewhere else in the middle of the Mediterranean Sea. You can see as well in the middle here is the level of this gas, NO2, that tell you the level of pollution around the town. You can see as well here close to India, you can see the small track and tell you as well the boats on where is the boats where they travel, and you can see that in this area the level of pollution is higher. And here on the right is quite impressive. So you can see, let's start. It's going to start again. So it's almost during 1 year. You can see the changement of temperature. Voilà, you see in the Mediterranean Sea. So it's almost a bit more than 5 degrees Celsius. The increase of temperature is almost 1 year in the Mediterranean Sea. So you can see with this just Earth observation, you can do a lot of different application of observing the Earth. You can do as well some moisture monitoring, so you can check the level of water that has been dropped on different area, and therefore you can do some smart farming. So it's here on the right. You can, depending on the level of rain, you can say, okay, these crops here will work well, and this one a bit less, because the level of rain has changed. I think there is a team here working on smart farming, and I have maybe some interesting link at the end. You can do as well some monitoring. So here to help for rescue and disaster team. So here is the picture of a flooding. So if you have the map of before the flooding and after the flooding, and you can compare both, and you can see which area has been the most, let's say, targeted by the flooding, and you can say to the rescue team, okay, you have to go here first. Or if, for example, if the infrastructure, if a bridge is not working, under flooding, you can say to the team, no, don't go this way, you can go that way. So that's all kind of example. You can as well do, let's say, before the flooding happen, you can forecast that there will be a heavy rain, and you can predict more or less where the flooding will happen. And so you can send SMS to the population and say, please evacuate. We have a flooding in this area. So all this mechanism is already in place. You can see there is an international charter space and major disaster. So that's whatever country can request it, and it can be sent to let's say the disaster authority in the governments to be able to monitor what happened in their country. You can use it, I don't know, for tsunami or for earthquake, all this kind of thing. You can before and after, you can help a lot the rescue team to be much more efficient. You can do as well in terms of town developments. So you can see here in town in Tanzania, around 15 years, you can see the development in black, and in red below is the one where, let's say, the government didn't have the plan to build something here. So it's houses that has been bought illegally, let's say. But it can help them to say, okay, in this area, you need a more network of water, of electricity. So it can help to make more sustainable the development of the town, and make aware of the town hall in which area they need to have some improvements. This one as well is quite funny. I don't know if you recognize the area. It's in Dakar. So in gray on the right is the land, and on the left is the sea. And as usual, the red are the bad ones, and the green are the good ones. So here, the good ones refer to legal or illegal fishing. So each boat has a kind of a beacon where it's sent to satellites, and this kind of IP address. It tells you if the boat is allowed or not allowed to fish. And so the authority, which are in blue here, they have to hurry up, and they can catch and do some control of the red ones. So it's very, let's say, useful to be able to get the monitoring of the level of fishing in your country. So all that are just simple example, and you will see later that there is much more. But now I'm gonna jump to the other side, which is the achievements. So because so far it was only, let's say, Earth observation, so all the data from Earth looking at the ground. But here I will speak more how the technology that has been developed for Earth can be transferred directly for different projects on the ground. So this one is, for example, so when you're in space, you need to recycle as much as possible. So in the International Space Station, you recycle the urines to get the water and to be able to drink it. So to be able to reach these things, they develop a very special membrane, a ceramic membrane with very, very small hole that allow to filtrate the urines and get only the water. And this membrane has been used, for example, here in Morocco, in this example, where the water in the underground was full of nitrates and phosphates, and they succeed to clean this water and make it drinkable for the population. So I think here is 1,200 people that you can see here on the left, they are drinking the water. And there is a team up between these two companies here and plus the company locally in Morocco to set up the solar panel, as you can see on top, and the ceramic which are inside here to be able to filter the water. Another example is the spirulina. I don't know if you heard about it. So it's a bacteria. So it was used a long time ago on Earth. But let's say the space development boosts the research about the spirulina, because when you want to go to, I don't know, to Mars or to far away, you don't bring your cow, you don't bring your stump pot. You have to be as much as let's say efficient in terms of food. So a lot of research has been done on this spirulina, which is a bacteria that you can harvest, and it's a very, very good diet complement with a very high level of proteins, vitamin A, and iron. So the transfer has been done on Congo, for example, is here, when they teach population how to cultivate and harvest the spirulina, and you can dry it, make powder, and you can put it on your food. It's a bit salty, but you have a highly supplement in terms of diets. And here on the right, that's enough for a family of 6 persons for 1 year. Yeah, you just put it there, you harvest it, and it's you just need a temperature, hot temperature, and it's a bacteria, so it grows by itself. Another example, as I was saying before, is like you can set up, let's say here, it's an example where thanks to an antenna in a very remote area, you can create some banking services. So here is with the antenna which are there, they're linked to satellites, and you can transfer money or make exchange. So you can develop services about banking, and as well companies that can grow around this bank because they have access to money. So that's allowed to have, let's say, an increasing of the services in remote area, especially linked to the money, to the ATM, for example. Another example here. So on the top, you have an image of a satellite. So it's a telecommunication satellite. So it's 36,000 kilometers away from Earth, and it can live for 15 years alone, and he has to work during these 15 years. So there is a very, very high requirement in terms of reliability of the components, especially the electronic. And below, you have artificial heart. So the technique of the technology design and the know-how and the design strategy has been applied from this satellite of telecommunication to develop this artificial heart. So both have the same requirement of very high reliability. I mean, even the heart is very close, but he has to work, I don't know, is 35 million beats per year. So he has to be on the beat. Another example is telemedicine. So you can, where the people are in space, there is no doctor 24/7 that you can call. I mean, that you can call, they can go up to space. He's on Earth, and remotely he can operate an echograph, for example, and move and do the diagnostic of what you have remotely. So that's very useful, for example, for the boat here, if you have for military, or even if you have remote area on Earth, you can just set up an echograph system. So like this, it's very basic. You just need an operator, no need a doctor, and remotely the doctor can move the echograph and be able to do the diagnostic. So you need to move the population is remotely that the doctor is operating the machine. And that as well, it's another example of full monitoring diagnostic. So this machine here, it can, let's say, it monitor your full body constantly, and it sends the data to the hospital, and so if something happens, the hospital will know it. So it's kind of used, you're still allowed to move, even if you have some problems, but thanks to this full system that takes all your data of the measurements and transmit directly on live on the hospital. They can know if something happens to you. Another example in terms of education. So again, thanks to the antenna here, some population in remote area can have access to education or material that is much more content in terms of the material because they can have access to internet and therefore download and have it much more, let's say, communication with the outside world. Sorry, to more content. That's called satellite wave for education. In terms of clean energy, on the right here, on the left, sorry, you can monitor the level of water in the dam, and it can help you to say, forecast what is the level of electricity that you will have, and to manage the electricity network that will be in the city for after. So you can know, okay, in a few days, in a few months, we will not have enough water, so we need to manage differently our procurement of electricity. Another example in electricity, here it was for Mars exploration, so they want to dig into Mars at a deepness of, 2-3 meters. But if you just take a normal rotary drill, you just scratch the surface, you don't go deep enough. So this company here, Zaptec, have developed a plasma drilling, you can see here. And for that, they had to transform the electricity coming from the solar panel into a specific kind of electricity to be able to operate this plasma. And this transformation of electricity has been used now. You can use it as a transformator to recharge your car. And you can plug this transformator in whatever plug here. So you don't need a very specific plug to be able to recharge your battery. You can do it everywhere. So that's an example of transfer of technology. To reduce inequality as well, on the left here, you have a woman which is visually impaired or blind. And thanks to the keyboard that she has on the left, she's able to enter a new place where she wants to go. And thanks to the satellites, it can tell her where to go. Because the problem with the dogs is that they can only go to known place, not new place. And here on the right, I don't know if you know, it's a parabolic flight. So it's a flight where for a few seconds you feel in gravity, without gravity, so with zero gravity. And that's just for people with, here is a case of people with motor handicap, to feel, let's say, without any gravity. Up to now, I just presented, let's say, example. I've done before. How did I say, how much you think it will cost per year and per person in Europe? You can think that it's very expensive, but no, it's only 2 tickets cinema per year per person in Europe. That's the budget of the European Space Agency.
Cinema is expensive.
Yeah.
Cinema is expensive.
How much is the cinema
3D,
ticket?
well, €9.
So it's 18
Hier, chef de
euros.
pâté car. In 3D, yeah. You can find much more other examples here in this website here of, let's say, what space has been done for a transfer to Earth. But let's say right now, I just show you example of what has been done. And I see very beautiful mind here with very bright ideas. So I want to give you some links for you to, let's say, explore, to contact people, and to be able to, let's say, make the bridge between space or data from space and your ideas here. So the first website is Copernicus, where you can have access to the data from Earth observation. And it's for free. Huh? It's part of the European Union. So the services, the first one, you can have a map of and data of the quality of the air. You can have as well, for the water, what is the level of the oceanographic forecast. You can see as well the pollution in the air and the source, so which chemical component is it. You can have as well to see if the forest is going well or not by the level of green of leaves. So all that is available through this website. There is another one where you want, if you want to make your own startup. Let's say ESA is proposing some kickstart activities, and the activity can be funded up to 75%, up to 60 kilo euro. for your company if the contract is successful, and you can have all the support for the network of ESA. And I just put an example here of one of the Kickstarter activity that is gonna open soon. And I think the topic is very interesting for you, is the value of space to virtual and augmented reality. So if you have ideas, please feel free to apply. There is another one which is here is a bit more difficult, is let's say the list of all the space technologies that has been identified as possibly being useful on Earth. So here is a case of satellite altimetry method and system with Doppler effect compensation. What does it mean? It means that you can just improve your accuracy of your altimetry. So you can have a very good knowledge on how high you are. And you can see here on the bottom, so there is a small description, but you can see the domain of application of possible application is agriculture, forestry, fishing, animal, and related products. So here, if you have ideas of something and you miss hardware, you can have a look here, and you can say, okay, this hardware can help me to do my ID. And my last slide, I think, I like it a lot. So here is just the link of the space incubator. So it's already companies that are linked to ESA, that they already provide services. I just put some of them. So the first one is Goodwood. So it's providing almost real-time data about the forests. So it's to prevent illegal logging or mining. Here is the smart farm sensing here for the team. Is to do obviously a farm sensing, a smart farm, sorry. There is a space for good. So here as well, they are really targeted, this startup is directly targeted toward the SDGs. So they do a lot of different things, and all of them are for the SDGs. And Blackshore, this one, so I just put the example of Blackshore here, what they did once. So there's been a typhoon in 2013 in the Philippines, and they had the idea of launching a game. So people with the game, so it was the data from where they were, and they had to make annotation of the game of, okay, this bridge is broken, or here this house is down. And so people were playing, and so they were, say, giving more knowledge to the map of the original map. And this, say, augmented knowledge in the map has been feedback to the rescue team. And so the rescue team could have more access or to be more efficient in the way they will rescue on the field. So I found that fantastic because it's mixing game with a lot of people, and as well helping the others thanks to this map with augmented knowledge, let's say. So I hope I convince you that space technology can be used can support the Earth observation, the Earth sustainable development. You can see that the clock is ticking, so please embrace one of the goal, go for it. But let's say we can keep chasing the stars, keep exploring the universe, but we should not forget from where we are coming from, Earth.
Yeah.
Thank you so much, Pierre Elie, for this. I think it was a beautiful walkthrough, like a little manual on all the different ways we can, first of all, benefit from satellite data, and also influence and here on Earth the technologies by satellite data. I want to open the floor with the two questions, particularly for me. How open or how accessible is that satellite data? You already showed some examples. That is the first question. And the second question, I want to elaborate further in that last example of including gamifications to give kind of feedback information to the satellite. So how can we, as a digital society, collaborate with those technologies? How can we design technological processes, keeping in mind the capabilities we have from above? So these are the two questions. How can we push these collaborations further?
So for the first one, in terms of access to the data, So the one that I presented, they are, as most of them are free accesses. It's only the one concerning the disaster. So
Yeah.
you know the chart of disasters, and this one are only for, let's say, public authority that have the disaster management. So this one are not, let's say, oh, you have to apply for it,
Yeah.
and they accept it or not.
Yeah.
So. But all the others is like in terms of forests and the oceanography, this one are free access.
Okay.
And in terms of what the DSS can do, I mean, I think in terms of they can develop a lot of application, serious game, that will be a fantastic thing, I think, and to be able to use the data from space to increase the knowledge about it, either to make, as it was written here, to help the rescue team, or I don't know, to prevent illegal deforestation, for example, because you can go to Africa and send the team in the forest and say, okay, this tree was not here before, or that there is new area that was used to be tree but not anymore. So all this kind of thing.
All right. Thank you so much. I want to open the floor for a few questions. So if you have a question for Pierre Elie, maybe just raise your hand. Emma?
Thanks. I'm gonna start with a really crazy question. We are using a lot of servers to process data on Earth, and those servers, they get overheated, and it seems to be very cold up there in space. So how feasible would it be to put like some of our servers in space and like communicate the data once the results are processed, and then the servers would be cooled more easily without using any extra energy?
Maybe you would need heating fans.
Yeah, you would need heating fans.
Yes, so far the servers doesn't work in vacuum and in very, very cold temperature. So either you find new technology where they can work in, I think I've seen some of them could work in I see, but yeah, you have to launch big things, and that costs a lot. And after, in terms of data access, yeah, you will need a kind of FIFO or a buffer to be able to access the data. But I think the most difficult part is just you have to launch a big server, and that costs a lot in terms of launching a payload which is very a lot of mass.
But would it be bigger than an actual space station? Like, not necessarily. There's already a lot of computers up there.
There is some of the computer, but you can data download.
Yes, yes. So
So
it's not like
You want to
moving
put the server, you want to put the server in space.
Yeah.
Yeah. Yeah, it's a crazy idea.
It is indeed a crazy idea. I feel like crazy ideas here.
It's just the physics, the scientific reason behind is not very high, but
it's save energy.
but it's save energy. Yeah.
Should we take another question? Anyone else has a question to ask? Right. Maybe I have another question. You mentioned a lot of kind of functional applications for using satellite data on Earth, whether it is for police enforcement, for law enforcement, for measuring levels in a dam. But I'm also very interested in occasions where that utilization has gone bad, where you try to kind of use satellite data for something on the Earth, and it backfired. So are there any warnings, for example? So are there any anomalies that have occurred, for example, and they weren't logical in that social context?
Yeah. You mean in terms of data which are not good?
Yeah, could be misleading data.
Use.
Could be misleading data. I don't know exactly what could happen, but I'm sure there are warning
Yeah, you
signs.
have, so that's why in the link that I put, So
Okay.
there is the raw data,
Yeah.
and this one are not very useful at your level because they are very raw and you don't know what you see.
Yeah.
So that's why there is they provide services to already have processed data and to remove the spurious things to avoid the misinterpretation. No, you're right. The interpretation of the data has to be very, very careful, and that has to be done, let's say, earlier by specialists. And the release of the data has to be has to be confident in what has been given to the public. Yeah, I'm not aware of any it's a misinterpretation of the data that's been provided to the public. No.
Okay.
Sorry.
All right. There is a question at the back. Two questions at the back, but I don't know if this can go all the way. Yeah.
Thank you. So we've seen that investments in space are decreasing a lot. At least that's what I read. Would you state that then we are actually doing Earth by not investing in space?
Given the price of it, I would say it would be a kind of waste of money to not going there. And still, we still need to go to space. Just first for our pioneer spirits, and but as well to help Earth thanks to all these developments. So there is a lot of development I provided here. For example, the ceramic filters or the spirulina is only space that boosts the development because the requirement because only space can provide this kind of requirements.
But what you see in popular opinion is that people, when you have problems on Earth, you probably want to focus on Earth, but actually it's contradictory. You say focus on space.
Yeah, given the price of 2 tickets of cinema per year, it's not that much indeed.
You're a good salesman. Thanks.
Any other questions? Balka.
So what if I have a lot of money? Would I be able to just send out any satellite that can collect all kinds of data? Or is there some kind of regulatory organ or something that says, okay, you can collect this data but not this data?
Yeah, there is space law. There is
Space law. Wow.
Yeah, it's a very new field, and they should not be so much behind
the 1960s.
compared to the technology developments. So there is. So you have to, let's say, when you launch something, you have to be sure that if something wrong happened during the launching, there is not so much people below. And when you are on top, let's say when you are in your orbit, you have, for example, you have to think about the end of life of the satellite. So you have to clean the space after when the satellite is not here anymore. So you have to think about all the processes, and you have to you have to keep some propellant enough to be able to let the satellite disintegrate into the atmosphere and not polluting the space.
But I mean more in terms of collecting data. Sometimes, as you see on websites now, you have to ask for permission to collect some kind of data. But if you have a private satellite up in space, you can collect all kinds of data. Is there any rules about that?
No, you just have to be careful for the military.
Yeah.
Just go a little bit over theirs.
Yeah, so you will see less. No, there is. I don't think so. There is a. No, it's space belongs to everybody, and you have to comply with regulation when you launch, for example, or the end of life. But what you have inside the payload, so as the image that you take and the use that you do with it. No, if you are very rich, go ahead.
Thanks.
Yeah. There is a question from the back. Yeah.
Many interesting projects, but what are you working on right now? Can you maybe explain a bit?
It's a good question.
Yeah, right now, yeah. So I'm working on the project for Euclid, for example, that will map the dark energy and dark matter in the universe by looking at galaxies and a group of galaxies. And so I'm doing some tests in the infrared sensor, like latency persistence. So if you look at the sun, I mean, you should not, and after you look somewhere else, you still have the remanence, the lag of the image in your eyes. And this sensor have the same problem. And so I'm studying how we can decrease this level of lag for this sensor. So I'm putting some light, and after I switch off, and I check if there is still some latency image on this sensor. That's what I'm doing right now, and I'm giving support as well to mission that will go to Jupiter in 2 years. Another one that will look for the chemical composition of atmosphere of exoplanets. So just to see if what is in the atmosphere of planets which are outside of the solar system, if there is, I don't know, water, carbon, methane, this kind of thing. That's my daily work.
There's a question here.
Yeah, I have a question because I wasn't really aware about the amount of data that is currently shared. For instance, about the satellite data, about the amount of trees that are growing. Don't you think there is some kind of problem with the public image of science? Because you have so much data, so much knowledge, so much experience, but you hardly portray any on society apart from media you make publicly available, but don't really market. You're not marketeers, but there is like a huge gap between the population and the science community.
That's why I'm here tonight as well.
True. True.
There is as well, let's say, that's why one is one of the last slides. Instead of having the classic, let's say, pipeline of the data from the satellites, the scientists that make the analysis and after that share the knowledge to the people, you can skip a bit the scientists, or at least have the help from everybody around the world to as well look at the data and see some features that maybe the scientists miss. That happens, for example, for data on Mars. They were free, and people will look at data and say, hey, here I see something, or it looks like this, like this, and that where some scientists didn't see it. So that's why now I think we have to as well include as much as possible as well people in the data processing to feel them included as well in the space exploration.
Any other questions? Yeah, Carlo.
What do you think, or are you planning or dreaming to collect data in the future? So which kind of data are you planning or dreaming to collect in the future from space?
Good question.
On my personal opinion, I mean, as you say, we have for the SDGs we have a lot of data, and let's say the best example would be to involve just more people into the data processing in terms of the data themselves. No, I mean, I would love to see a signal where we can see life on our other planets. That's personal.
There is a computer project. It was a crowd-sourced computer project in the 80s, I think, to process a satellite looking for life on other planets, or to decipher satellite messages. It's called something at home. I don't know, but yeah, there's it's I think developed in the University of Berkeley. City at home, yeah.
Ah, no, that's the big
City at home, yeah. Thank you.
That's the big antenna which is in Puerto Rico, and that looks at for rain.
I think it's still happening.
You know, in James Bond, one of them they are fighting around,
around that arena. Right? Okay, I didn't know that. I didn't, but I know it's still happening. It's called the BOINC now, the project, if anyone's really interested. I don't know why I know this. Any other questions?
Yeah, you said you've examined a lot of exoplanets, for example. Has there ever been any data that you have seen? You're like, maybe there's life out there. Maybe this is from aliens.
We moved somewhere else.
Yeah. I'm more in the engineering side, but there is somebody here in the audience, which is here, that know a lot about exoplanets.
Yeah.
Nicolas, have you seen some data that you say, hey, there's life out there?
We are not there yet. We're trying to. We're just measuring some composition of atmospheres, but from this point to know if there is something on these planets, it's several decades away.
That's not the answer we want to hear.
I saw something.
But it's going really fast.
Yeah.
Very recent alien would look at Earth and Earth's atmosphere. Would they know that we're here based on our atmosphere?
Yeah.
Based on the
If they have the
atmosphere.
good, it has the good tools to see our atmospheres, and they see change of chemical composition, for example, of atmospheres, and they can say, so, oh, this area here, I don't know, above the airport, you get more pollution, so you say here decrease or high, so you see some activities, but you don't know what is happening below. But it's the change that tell you that something happened below.
So I have one last question. Does anyone else have a question? So we can a pressing question. Okay, so we asked the pressing question.
It was a crazy idea.
It's not about my crazy idea now. It's about the crazy ideas that you see in movies. So you were saying how space science can help us have a sustainable planet. And in movies, you see a lot of fantastic, visionary future of space science where we would actually colonize exoplanets. And I have the intuition that some people, and I don't know how much, can take this as like, okay, well, we might pollute it, but then we'll find an exoplanet. So,
I see an answer.
We have to clean first home before going away, and going away is very, very far away. So far, what is this? Proxima Centaur is at 4 light years from here. So the first exoplanet is very, very far away, and it takes billions of years to go there with the actual propulsion system that we have. So we are not yet ready to go somewhere else.
Do you think we may invent warp drive anytime soon?
I think there's a lot of more questions happening, but I think the conversation can continue beyond the setting. So I think you can talk to Pierre Elie after this. And I really want to thank him a lot and present him with a very, very tiny gift from DSS. So he can now really represent the SDGs. And thank you so much. Guys, have a beer, bingo. Ask Pierre about exoplanets.
Who's in here?
Yes, that's what I was afraid the answer that I was going to get from my question. That's classified.
Thanks.
The chair behind you, and then the other
C'est de l'archivage. C'est pas le ratio entre le stocké au sol, le carrier.
Very nice. Thank you. Yeah, I like it very much. Do you think you can record your like a little in a few words what you said? Oh yeah, and I want to record how you drop the mic as a close-up as well. So maybe we can record it here.
What do I have to say?
Sorry?
What do I have to say?
First let's drop the mic. Okay. That's easy. Yeah, have you ever worked with André Kuipers?
No.
This is my nephew.
Ah, yeah.
Yeah. It's so funny. I had to think like, oh maybe you know this guy.
That was great. Thank you. Nice. I'm in future missions, so I'm looking at astrophysics.
Marco!
That's me.
1 second, let's turn the mic on. Okay, let's see. How can I do this? Okay, if you can just do it like this, and then you can just like walk off.
Look cool. Look at me. I have to target. Okay, yeah.
1 second, let me focus. Oh wait. No, one more time. Sorry, I wasn't going yet. Oh yeah. Good practice is always good. 1 sec. Yeah. Yes, recording. Awesome. Nice. You want to see it?
Yeah.
It's like a very slow-mo. Super slow-mo.
Oh, you look cool.
Boom. Nice. Okay. I have this shotgun microphone.